Jupiter is the largest planet in the solar system, yet there is nowhere you could ever stand. It exists as a vast, quiet presence, shaping the motion of the worlds around it. Not loudly, not dramatically, simply by being there, heavy enough to keep order from falling apart. And because of that, this feels almost contradictory. A planet so immense, yet without anything resembling solid ground. No rocky surface, no clear boundary where you could say this is where the surface begins. Instead of standing still, everything on Jupiter drifts, layer upon layer, not separated by sharp lines, but by slow, gradual transitions. Here, the ideas of outside and inside do not divide as neatly as we are used to. Perhaps Jupiter was never meant to be stood upon. It exists to remind us that in the universe, some worlds do not need solid ground to have meaning. To understand why this feels so natural, we need to begin with something very familiar: the way humans think about what a surface is. On Earth, the idea of a surface feels natural and unquestioned. We wake up each day standing on something solid. Floors support our weight. Roads hold us steady. Even when we sit or lie down, there is always a firm boundary beneath us. From our earliest experiences, a surface is where motion stops. It is the place where falling ends and balance begins. Because of this, the human brain quietly treats a solid surface as a requirement for existence. If something is real, we assume it must have a ground. This assumption is not philosophical at first, it is biological. Our bodies evolved to survive by finding stable footing. Standing upright requires predictability. Walking safely depends on resistance beneath our feet. Over time, the brain learned to associate safety with solidity. That is why, when we imagine another world, we instinctively picture a place we could stand. A landscape, a horizon, a surface that separates above from below. Even when we think about distant planets, we tend to recreate Earth in quieter forms. But this instinct, while useful, is also limited. On Earth, a solid surface exists because of how our planet formed. Rocky material gathered early, cooled, and remained stable. Gravity compressed that material into layers that no longer drift. The result is a clear boundary between atmosphere and ground. This is typical of what astronomers call terrestrial planets. Worlds made primarily of rock and metal. Mercury, Venus, Earth, and Mars all share this basic structure. They have surfaces because their materials allow one to form and remain fixed over time. Gas giants are different in a fundamental way. Planets like Jupiter did not form from solid material in the same manner. They accumulated enormous amounts of hydrogen and helium, the lightest elements in the universe. These elements behave very differently under gravity than rock does. They compress, flow, and change gradually rather than locking into place. As a result, the idea of a surface begins to lose meaning. On a gas giant, there is no simple line where atmosphere ends and ground begins. Instead, conditions shift slowly. Pressure increases, density rises. What was once thin gas becomes thicker, heavier, and more resistant. But it never becomes a flaw in the way our minds expect. This difference is difficult for us to accept, not because it is complex, but because it challenges a deeply held assumption. We expect worlds to mirror our own experience. When they do not, we feel disoriented. Space rarely gives us simple answers. From a scientific perspective, a surface is not a requirement for a planet to exist. It is simply one possible outcome of planetary formation. Some worlds end in rock, others transition endlessly. Yet the human mind continues to search for a stopping point, a final layer, a place where motion gives way to rest. This search is not wrong. It is human. Even scientists, trained to think abstractly, often describe planets using language rooted in Earth-based intuition. We talk about depth, descent, and interiors as if we are moving through familiar spaces. In reality, many of these environments do not offer such clear divisions. Silence is also a kind of data. When a planet lacks a surface, it is not unfinished. It is not missing something. It is simply operating under a different set of physical rules. Rules that do not prioritize stability, but continuity. Understanding this requires us to loosen our grip on everyday experience, to allow for the possibility that existence does not always come with firm boundaries. As we move deeper into Jupiter's nature, this shift in perspective becomes essential. Not every world needs a place to stand. Some worlds exist as transitions rather than destinations, and perhaps in learning to accept that, we begin to see the universe not as a collection of solid places, but as a spectrum of states, quietly unfolding without the need for firm ground. When we first hear that Jupiter is a gas giant, the description sounds simple. A massive sphere made of gas, light, airy, something almost cloud-like. But that picture is misleading. Jupiter is not gas in the way we experience gas on Earth. It is not a floating balloon. It is not a hollow shell with emptiness beneath it. Calling Jupiter a planet made of gas is convenient but incomplete. On Earth, gas behaves gently. Air spreads out. It fills rooms. It rises and falls easily. Its weight is barely noticeable. On Jupiter, gas behaves very differently. Hydrogen and helium make up most of the planet, but they are held under immense gravity. As you move deeper into Jupiter, these gases do not disappear. They do not suddenly turn into something else. They are slowly compressed, layer by layer, becoming denser, heavier, and more resistant to motion. This is where the idea of Jupiter as a simple sphere begins to fall apart. Instead of a clear surface and a defined interior, Jupiter has a gradual structure. Not layers in the way we stack solid materials, but layers of condition. Temperature changes, pressure increases, density rises. There is no single point where one state ends and another begins. If you could descend into Jupiter, you would not pass through a doorway from atmosphere to ground. You would move through zones, each one slightly different from the last, each one shaped by gravity rather than solidity. This layered structure is central to understanding why Jupiter has no surface. On rocky planets, the boundary between air and ground is sharp. You can draw a line. Above it, gas. Below it, solid matter. Jupiter does not offer that clarity. Hydrogen and helium remain in motion even as they compress. They flow, they shift, they respond to pressure instead of resisting it. As gravity squeezes them tighter, their behavior changes, but not abruptly. At greater depths, the gas becomes thick enough to feel almost liquid-like. Not because it turns into a liquid in the everyday sense, but because density increases. Particles are packed closer together. Movement slows. Resistance grows. Yet even here, there is no ground. There is no moment where you could say this is where the planet begins. There is no stable surface to mark an arrival. This challenges how we think about planets. We are used to worlds with clear boundaries. We like edges. They help us define where something is and what it is not. Jupiter refuses to offer that comfort. Space rarely gives us simple answers. From a scientific perspective, Jupiter is best understood as a continuous body rather than a layered object with fixed borders. Its structure changes smoothly with depth. Every region blends into the next. This continuity is why scientists describe Jupiter using profiles instead of surfaces. Pressure profiles, temperature gradients, density curves. These are not the language of solid ground. They are the language of transition. Numbers whisper more than they speak. There is also a human element to this difficulty. we instinctively search for a point of reference, a place to stop, a boundary that tells us we have arrived somewhere meaningful. Jupiter offers none. Instead, it invites us to think differently, to imagine a planet not as a place but as a process, a world defined by motion rather than rest. Hydrogen and helium are not still. They circulate, they convect, they respond continuously to heat rising from the planet's interior and cooling at its upper layers. This movement further prevents any solid boundary from forming. Even deep within Jupiter, where conditions become extreme, matter does not settle into a stable surface. It remains part of a dynamic system. Silence is also a kind of data. The absence of a surface is not a flaw in Jupiter's design. It is a natural consequence of how the planet formed and how its materials behave under gravity. Jupiter does not lack something Earth has, it simply follows different rules. As we move forward, this idea becomes essential. To understand Jupiter, we must stop looking for a ground that does not exist. We must learn to think in terms of depth, pressure, and gradual change rather than flaws and edges. And perhaps that is the quiet lesson Jupiter offers here. Some worlds are not meant to be divided into clear layers. They exist as continuous transitions, reminding us that not everything meaningful in the universe comes with a place to stand. Pressure is a quiet force on Earth. We live inside it without noticing. Air presses gently on our bodies from every direction, yet it rarely demands our attention. We breathe, we move, we stand, all without feeling the weight of the atmosphere around us. Because of that, pressure often feels abstract, something measured by instruments rather than experienced directly. On Jupiter, pressure is not abstract at all. It is the defining condition of the planet. As one moves deeper into Jupiter, pressure increases steadily and without interruption. There is no sudden moment where conditions dramatically change. No sharp boundary announces a new environment. Instead, pressure grows continuously with depth, shaped by the immense weight of everything above. Each layer presses down on the next, creating a slow and relentless compression. Near the upper layers of Jupiter's atmosphere, hydrogen and helium behave much as gases do on Earth. They flow freely, mix easily, and respond gently to changes in temperature. But Jupiter's gravity never relaxes. With increasing depth, the space between gas particles shrinks. Collisions become more frequent. Movement grows more constrained. Density rises. The gas does not vanish as this happens. It does not fade away or turn into empty space. It remains present, but it begins to behave differently. This is one of the most important ideas to understand. On Jupiter, gas does not disappear. It transforms. We often imagine gas as something light, fleeting, and incapable of supporting weight. That intuition comes from our experience under low pressure. Under enough pressure, however, gas begins to lose its freedom. It resists motion. It flows more slowly. It starts to feel substantial, even though it has not become solid. As hydrogen is compressed deeper inside Jupiter, it gradually stops behaving like the gas we know. It does not undergo a sudden phase change. There is no clear point where one could say the gas has become something else. Instead, its properties shift smoothly as pressure increases. Hydrogen grows dense enough to behave almost like a fluid, not because it turns into liquid in the everyday sense, but because particles are forced closer together and can no longer move independently. Space rarely gives us simple answers. This gradual transformation is central to understanding why Jupiter has no solid surface. A surface requires more than density. It requires stability. On Earth, solid ground exists because atoms lock into fixed arrangements that remain stable over long periods of time. Gravity holds them in place, but the surrounding conditions allow that structure to persist. Jupiter does not offer such conditions. Pressure continues to rise with depth, and temperature increases as well. Heat from the planet's interior constantly injects energy into the system. Matter is never allowed to settle into a calm, unmoving state. Even as hydrogen becomes denser, it remains part of a dynamic environment, always adjusting, always responding to forces around it. Numbers whisper more than they speak. Scientists describe the pressures inside Jupiter using figures measured in millions of Earth atmospheres. But the exact numbers matter less than what they represent. They tell us that no region inside Jupiter is isolated. Every layer influences the ones above and below it. Conditions are always changing, always connected. A solid surface is not just dense material. It is material that has reached equilibrium, a balance between pressure, temperature, and structure that remains stable over time. Jupiter never reaches that balance. Instead, it exists as a set of gradients. Pressure increases smoothly. Temperature rises gradually. Density changes without sharp boundaries. From a human perspective, this is deeply unfamiliar. We are accustomed to thresholds, to places where one state ends and another begins. We look for moments of arrival, for points where motion gives way to rest. Descending into Jupiter would offer none of that. There would be no landing, no final step, no clear moment where falling ends, only increasing resistance and increasing pressure. Silence is also a kind of data. The absence of a surface on Jupiter is not a failure of formation. It is a natural outcome of the planet's immense mass. Jupiter is simply too large, too compressed, and too energetic for solidity to emerge in the way we expect. Pressure pushes matter into new behaviors before stability can form. Heat keeps particles moving. Gravity keeps everything layered and in motion. Together, these forces prevent the formation of ground. Jupiter's interior is not chaotic. It is orderly and predictable, governed by physical laws we understand well. What it lacks is stillness. On Earth, surfaces exist because motion has slowed enough to allow them. On Jupiter, motion never slows that much. And so the deeper one goes, the less meaningful the idea of a surface becomes. Instead of asking where Jupiter's surface is, scientists ask how pressure changes with depth, how hydrogen responds to compression, and how energy moves through the planet. These questions replace the search for solid ground. Perhaps that is the quiet lesson pressure offers on this immense world. Stability is not guaranteed by size or strength alone. Some planets exist not as destinations, but as continuous transformations, reminding us that solidity is only one of many ways the universe can choose to exist. One of the most useful ways to imagine Jupiter is not as a planet with a surface, but as an ocean without shores. From a distance, its bands and storms look like features painted on a sphere. Up close, they behave more like waves and currents, constantly in motion, never settling into fixed shapes. Jupiter is not built around a place to arrive. It is built around continuous movement. When we look at images of Jupiter, we naturally focus on the clouds. The colorful bands, the swirling patterns, the slow rotation of massive storms. These features feel familiar. On Earth, clouds float above solid ground. They mark weather, not structure. We assume something firm lies beneath them. On Jupiter, that assumption quietly fails. The cloud layers we see are not surfaces. They are not boundaries. They are regions where temperature, chemistry, and pressure briefly combine in a way that makes clouds visible. Ammonia, water vapor, and other compounds condense at certain altitudes, forming bands that our eyes can detect. These layers tell us where conditions allow clouds to exist, not where the planet begins. Below each visible layer, conditions continue to change. Pressure increases, temperature rises, composition shifts, yet nothing stops. There is no moment where one could say this is where the clouds end and the planet starts. The clouds are part of the planet, not something resting on top of it. This is why Jupiter can feel deceptive when we observe it. What we see gives the impression of depth without offering a place to stand. Vision suggests structure, but touch would find none. The difference between seeing and standing becomes essential here. On Earth, vision and touch usually agree. When we see a mountain or a horizon, we know there is solid ground beneath it. Our senses reinforce one another. On Jupiter, they do not. What looks like a surface is only a change in appearance, not a change in substance. Space rarely gives us simple answers. If one could descend through Jupiter's atmosphere, the experience would resemble moving through a vast, deep ocean rather than approaching land. There would be no shoreline, no gradual shallowing, no sand beneath the feet. Only increasing resistance, increasing pressure, and a sense of moving deeper rather than downward. The idea of depth replaces the idea of height. Instead of asking how far above the surface one is, the more meaningful question becomes how much material lies overhead. Jupiter is defined by what presses down, not by what supports from below. This continuous transition is what makes the concept of a surface so difficult to apply. On Earth, surfaces mark transitions that matter for survival. Air becomes ground. Falling ends. Standing begins. Jupiter offers no such moment. Every layer flows into the next. What begins as thin gas slowly becomes thick, heavy, and resistant. Not abruptly, not dramatically, simply through accumulation. Gravity compresses everything gently but relentlessly, shaping a planet where change is gradual and unbroken. Numbers whisper more than they speak. Scientists describe Jupiter's interior using curves rather than lines. Pressure curves, density gradients, temperature profiles. These descriptions reflect the reality that there are no sharp borders to point to. The planet is a continuum, not a stack of layers separated by edges. This can feel unsettling, especially from a human perspective. We rely on boundaries to orient ourselves. We use surfaces to define where we are and where we are not. Without them, space becomes harder to navigate, even conceptually. Yet, Jupiter does not need boundaries to function. Its storms form, its energy flows, its magnetic field emerges from deep within, shaped by motion and pressure rather than solid ground. Everything works, even without a place to stand. Silence is also a kind of data. The absence of a surface tells us something important about how Jupiter exists. It is not incomplete. It is not unfinished. It is simply governed by different priorities than rocky worlds. Stability, in the sense we understand it, is not one of them. Instead of solidity, Jupiter offers continuity. Instead of edges, it offers gradients. Instead of stillness, it offers slow, persistent motion. These qualities are not flaws, they are expressions of scale. For humans, this challenges a deeply held intuition. We are accustomed to equating visibility with substance. If we can see something clearly, we assume it is there in a physical, tangible way. Jupiter reminds us that appearance and support are not the same thing. What looks like a surface may only be a moment in a transition. A brief alignment of conditions that allows something to be seen but not touched. As we learn to separate these ideas, our understanding of planets becomes quieter and more precise. We stop asking where Jupiter's surface is and begin asking how its interior changes. We shift from thinking in places to thinking in processes. Perhaps this is the deeper value of imagining Jupiter as an ocean without shores. It invites us to let go of the need for arrival. to accept that some worlds are not meant to be stood upon or crossed, but simply understood as they are. And in that acceptance, the universe feels less like a collection of destinations and more like a series of ongoing transitions, unfolding calmly without the need for firm ground. Deep inside Jupiter, there is a form of matter that feels unfamiliar even by cosmic standards. It is not something we encounter in daily life. It is not something the human body evolved to understand. Yet it plays a central role in explaining why Jupiter has no solid surface. This form of matter is known as metallic hydrogen. To approach metallic hydrogen calmly, it helps to begin with what hydrogen usually is. On Earth, hydrogen is the simplest and lightest element. It is a gas that rises easily, spreads quickly, and rarely stays contained without effort. When we imagine hydrogen, we picture something invisible and fleeting, something that escapes. Inside Jupiter, hydrogen behaves very differently. As hydrogen is drawn deeper into the planet by gravity, pressure increases steadily. The weight of the layers above forces hydrogen atoms closer together. Over immense depths, this pressure becomes so great that hydrogen can no longer behave as a free gas. The distance between atoms shrinks, their interactions change. Gradually, hydrogen begins to take on properties that resemble those of a metal. This does not happen suddenly. There is no sharp moment where hydrogen stops being gas and becomes something else. Instead, it transitions smoothly, responding continuously to pressure and temperature. This gradual shift is important. Metallic hydrogen is not a separate layer that sits beneath the clouds like a floor. It is part of an ongoing transformation. The word metallic can be misleading. It does not mean that hydrogen turns into a solid sheet of metal like iron or steel. It means that hydrogen's electrons begin to move freely, allowing it to conduct electricity. In this state, hydrogen behaves less like a gas and more like a fluid metal, dense, conductive, and responsive to magnetic forces. Yet even here, there is no ground. Metallic hydrogen does not form a surface because it does not settle into a stable, fixed structure. A surface requires stillness. It requires atoms to arrange themselves in repeating patterns that remain intact over time. Inside Jupiter, conditions never allow that to happen. Pressure continues to increase with depth. Temperature remains high. Energy flows constantly through the planet. Metallic hydrogen exists within this dynamic environment, not as a foundation, but as a region of behavior shaped by forces that never pause. Space rarely gives us simple answers. From a human perspective, metallic hydrogen challenges familiar categories. We are used to thinking in terms of solid, liquid, and gas. Metallic hydrogen does not fit neatly into any of these. It flows but resists. It conducts but does not harden. It is substantial, yet never firm. This ambiguity is not a flaw in our understanding. It reflects the reality of matter under extreme conditions. Inside Jupiter, nothing is allowed to remain fixed for long. Even as hydrogen enters its metallic state, it remains part of a vast circulation. Heat rises from deeper layers. Cooler material sinks from above. The planet churns slowly, constantly redistributing energy and matter. In such an environment, the idea of a surface loses meaning. A surface implies a pause, a stopping point, a region where motion ends and structure begins. Metallic hydrogen offers none of these. It exists as part of a continuum shaped by pressure and temperature rather than by stability. Numbers whisper more than they speak. Scientists estimate that a large portion of Jupiter's interior exists in this metallic hydrogen state, but the precise boundaries are less important than the behavior. Metallic hydrogen does not form a shell. It does not create a floor beneath the atmosphere. It blends gradually with the layers above and below it. This blending is essential to Jupiter's nature. It is what allows the planet to generate its powerful magnetic field. As metallic hydrogen moves and circulates, it carries electric currents. These currents give rise to magnetism, not through solid structure, but through motion. Once again, function does not require solidity. For humans, this is counterintuitive. We often associate strength and influence with firmness. We expect powerful things to be rigid. Jupiter reminds us that influence can come from movement instead. Metallic hydrogen is strong not because it is solid, but because it is dynamic. Its ability to conduct electricity depends on freedom of motion, not restriction. The very qualities that prevent it from forming a surface are the same qualities that allow it to shape the space around the planet. Silence is also a kind of data. The absence of a solid surface within metallic hydrogen tells us something important about planetary formation. Jupiter did not fail to become rocky. It never had the conditions required to do so. Its immense mass gathered light elements early, trapping them under pressures that favored transformation over consolidation. Rocky planets form surfaces because their materials cool and settle. Jupiter remained large, hot, and active. Its interior never slowed enough for solidity to take hold. This distinction is not a matter of age or complexity. It is a matter of balance. On Jupiter, pressure and temperature remain high enough to keep matter in motion. Metallic hydrogen exists precisely because equilibrium is never reached. For those listening quietly, there is something deeply human in this idea. We often search for foundations, for firm ground beneath complex systems. We want to know what lies underneath, what ultimately supports everything else. Jupiter offers a different answer. There is no final layer that supports all others. There is only ongoing transformation. Metallic hydrogen is not the end of the descent. It is simply another region in a long continuum. Below it, conditions continue to change. Above it, transitions reverse gradually. The planet has depth, but no flaw. Understanding this requires patience. It asks us to let go of the idea that matter must resolve into something solid to be complete. It invites us to accept that stability is not the only form of order. Numbers whisper more than they speak. When scientists model Jupiter's interior, they focus on gradients rather than boundaries. They track how properties shift with depth rather than where one thing ends and another begins. Metallic hydrogen appears not as a destination, but as a phase within a process. This way of thinking aligns with the broader lesson Jupiter offers. The planet is not defined by surfaces but by transitions, not by stillness but by slow, persistent motion. In everyday life, we rely on surfaces to orient ourselves. Floors tell us where we are. Walls define spaces. Without them, we feel unmoored. Jupiter removes these cues entirely, yet the planet remains coherent. Its structure holds, its influence extends far beyond itself. All of this happens without a single place where one could stand. Perhaps that is the quiet truth metallic hydrogen reveals. Matter does not need to become ground to matter. Influence does not require a foundation. Some of the most important structures in the universe are defined not by what they rest on, but by how they continue to change. And as we sit with that idea, calmly and without urgency, Jupiter becomes less alien and more instructive. A reminder that solidity is only one possible outcome of matter, and that the universe is under no obligation to provide us with a place to stand. From a distance, Jupiter appears calm. Its face is wrapped in wide bands of light and dark, gently circling the planet. The motion is slow enough that it feels almost still. But this calm is not the absence of movement. It is the presence of balance. The bright and dark cloud bands that define Jupiter's appearance are not decorative features. They are expressions of motion. Each band represents winds moving in opposite directions from its neighbors. Some flow eastward, others flow westward. They slide past one another without colliding, forming a pattern that has persisted for centuries of observation. On Earth, opposing winds often lead to instability. Weather systems collide. Storms intensify and dissipate quickly. On Jupiter, the opposite happens. The contrast between neighboring bands helps maintain order. The winds are strong, but they are organized. They follow paths shaped by the planet's rapid rotation and deep atmosphere. These alternating bands are a reminder that motion does not automatically mean chaos. Under the right conditions, motion can become structure. This becomes even more apparent when we consider Jupiter's storms. Some of them have lasted for generations. They change slowly, sometimes shrinking or shifting in shape, but they do not vanish easily. Their persistence is not a sign of violence, it is a sign of stability. A storm that lasts this long must be supported by a steady supply of energy. On Earth, storms draw energy from sunlight, heating the surface and oceans. When that energy fades, storms weaken. Jupiter's storms are different. They are sustained not primarily by sunlight, but by heat rising from within the planet itself. Jupiter emits more heat than it receives from the Sun. This internal heat is a quiet but constant presence. It originates deep inside the planet, left over from formation and maintained by slow gravitational contraction. That energy moves upward, layer by layer, shaping the behavior of the atmosphere. As heat rises, cooler material sinks. This process is known as convection. On Earth, convection happens in boiling water, in the atmosphere, and in the mantle beneath our feet. On Jupiter, convection operates on a planetary scale. The important difference is not the process itself, but the consistency. Jupiter's internal heat does not fluctuate dramatically. It does not switch on and off. It provides a steady input of energy that allows convection to organize rather than disrupt. Space rarely gives us simple answers. Convection inside Jupiter does not produce random turbulence. Instead, it feeds into the planet's rotation, reinforcing large-scale patterns. Rising heat helps maintain the jet streams that define the cloud bands. Sinking cooler material balances the flow. The result is a circulation system that is always active, yet rarely chaotic. This is difficult to reconcile with our everyday intuition. We often associate constant motion with instability. We expect systems that never rest to break apart. Jupiter challenges that assumption. Its atmosphere is in perpetual motion, yet it remains coherent. From a human perspective, this can feel almost reassuring. The idea that something can move endlessly without losing form suggests that stability does not require stillness, it requires balance. The winds on Jupiter reach remarkable speeds, far faster than most winds on Earth. Yet speed alone does not define their impact. Direction, structure, and interaction matter more. Jupiter's winds are guided by the planet's rotation, which stretches and aligns them into long, continuous flows. These flows act as boundaries, without being barriers. They separate regions of the atmosphere while allowing energy to move through them. This separation helps storms remain intact, rather than tear themselves apart. Numbers whisper more than they speak. Measurements of wind speed and temperature gradients tell scientists that Jupiter's atmosphere is deeply connected to its interior. The visible clouds are not isolated features. They are surface expressions of processes extending far below. What we see is only the uppermost layer of a much deeper system. This connection explains why Jupiter's storms can endure. They are not shallow phenomena. They are anchored in depth, supported by energy rising from below. Even as their shapes evolve, their underlying dynamics remain steady. Silence is also a kind of data. The absence of rapid change tells us something important. Jupiter's atmosphere does not need dramatic events to sustain itself. It relies on slow, continuous processes that rarely demand attention but never stop operating. This slow endurance contrasts sharply with the way we experience weather on Earth. Our storms are temporary. They come and go. Jupiter's storms feel more like long conversations than sudden outbursts. The planet's internal heat also reinforces the idea that Jupiter is not defined by surfaces. Without a solid boundary to absorb or reflect energy, heat moves through layers of gas and fluid matter. It circulates rather than settling. This circulation keeps the atmosphere alive with motion, yet prevents it from collapsing into disorder. In this sense, Jupiter behaves more like a living system than a static object. Energy enters, moves, transforms, and exits, all without the need for rigid structures. The planet maintains itself through flow rather than form. For those listening quietly, there is a subtle human lesson here. We often seek stability by trying to stop movement. We equate rest with control. Jupiter suggests another possibility. Stability can emerge from continuous motion, provided that motion is guided and balanced. The alternating cloud bands, the enduring storms, and the steady convection all point to the same truth. Jupiter is always changing, yet it remains recognizable. Its identity is not tied to stillness but to pattern. This is why the planet does not feel chaotic despite its immense energy. Chaos is unpredictable. Jupiter is predictable in its own slow way. Its winds follow paths, its heat follows gradients, its storms follow cycles measured in decades rather than days. Understanding this helps explain why Jupiter does not need a surface to be stable. Stability does not come from standing still. It comes from maintaining relationships between forces. Gravity, rotation, heat, and motion all play their roles, none overwhelming the others. Perhaps that is the quiet meaning of Jupiter's enduring dance. A world can move endlessly and still remain whole. Order does not require rigidity. It can arise from flow, from balance, and from patience, and as we let that idea settle, gently and without urgency, Jupiter begins to feel less distant. Not because it resembles Earth, but because it reflects a deeper principle. That even in constant motion, there can be calm. Gravity is one of the most familiar forces in our lives, yet also one of the most easily overlooked. We feel it every moment, holding us to the ground, guiding falling objects, keeping our feet where we expect them to be. Because it is constant, it rarely draws attention. We notice gravity most when it is absent, or when it behaves in ways we did not anticipate. On Jupiter, gravity is impossible to ignore. It is the planet's defining influence. Jupiter's immense mass creates a gravitational field strong enough to shape not only its own atmosphere, but the motion of objects far beyond it. This strength is not sudden or aggressive, it is steady and persistent, acting over long periods of time. Jupiter's gravity does not pull in short bursts, it works continuously, quietly adjusting paths and speeds. Anything that comes near the planet begins to feel its influence, long before it reaches the clouds. Trajectories bend, orbits stretch. Motion reorganizes itself around Jupiter's presence. Escaping Jupiter's gravity is not easy. The energy required to break free is far greater than what is needed to leave Earth. This does not mean that Jupiter traps everything that approaches it. Rather, it means that the planet strongly favors long-term relationships. Objects that enter its gravitational reach are likely to remain connected, moving in paths shaped by its mass. Space rarely gives us simple answers. Many of Jupiter's moons exist because of this gravitational influence. They were not placed gently into orbit. They were captured, guided, and stabilized over time. Jupiter's gravity provides a framework within which these moons can move predictably, even as they interact with one another. This influence extends far beyond the immediate vicinity of the planet. Jupiter plays a quiet but significant role in the architecture of the entire solar system. Its gravity affects the distribution of smaller bodies, the paths of comets, and the long-term stability of planetary orbits. In this sense, Jupiter acts less like a trap and more like an organizer. Its gravitational pull does not exist to capture indiscriminately. It exists to shape motion into patterns that can endure. From a human perspective, it is tempting to imagine gravity as something dangerous, a force that pulls things in and refuses to let go. This image comes from experiences with falling and impact. But gravity itself is neutral. It does not seek to harm, it simply connects masses across distance. On Jupiter, this connection is especially clear. The planet's gravity binds its atmosphere, holding vast layers of gas in place despite their motion. Without this pull, Jupiter's gases would drift away into space. Gravity provides the cohesion that allows the planet to exist as a single, recognizable world. Numbers whisper more than they speak. When scientists calculate Jupiter's gravitational influence, they often focus on how far it extends, rather than how strong it feels at any one point. The planet's reach is wide, affecting regions of space far beyond what we can see. This long reach allows Jupiter to act as a stabilizing presence over millions of years. This stabilization does not mean rigidity. Orbits can shift, paths can change, but they change within limits set by gravity. The force does not freeze motion, it channels it. This distinction matters. A trap restricts movement. Gravity enables structured movement. It allows objects to move freely within a system while maintaining coherence. Silence is also a kind of data. The absence of chaos in Jupiter's neighborhood tells us something important. Despite its size and strength, the planet does not disrupt the solar system. Instead, it contributes to its long-term order. Its gravity helps regulate the flow of material, guiding objects into predictable paths. Even the difficulty of escaping Jupiter's gravitational pull reflects this role. Energy must be applied deliberately to leave. Random motion is not enough. This ensures that interactions with Jupiter are meaningful rather than fleeting. For those listening quietly, there is a subtle human parallel here. We often think of structure as something imposed from above, something rigid and confining. Jupiter suggests another possibility. Structure can arise from consistent attraction rather than forceful control. The planet does not demand attention. It does not announce its influence. It simply remains massive, and in doing so, it shapes the space around it. Over time, that shaping becomes order. This is especially evident when considering Jupiter's role in protecting inner planets from excessive impacts. By influencing the paths of comets and debris, Jupiter helps reduce the frequency of close encounters elsewhere. It does not eliminate risk, but it moderates it. Once again, gravity operates through patience. Its effects accumulate slowly. The results are seen over long timescales rather than dramatic moments. Understanding gravity in this way helps clarify why Jupiter does not need a surface to exert influence. Its power does not come from standing still or resisting motion. It comes from being massive and persistent. The planet holds its atmosphere, its moons, and parts of the solar system together not by force but by presence. Gravity is not a wall. It is a relationship. As we move through this idea, Jupiter becomes easier to understand. Not as a giant obstacle in space, but as a quiet organizer. A body whose strength lies in its ability to maintain connections over time. Perhaps that is the calm truth at the heart of Jupiter's gravity. Order does not require rigidity. It requires consistency. And in the vastness of space, it is often the steady forces, acting without urgency, that shape the longest-lasting structures. When people speak about visiting Jupiter, the conversation often turns quickly toward technology. Stronger spacecraft, better shielding, more powerful engines. The idea is comforting. It suggests that distance and danger are problems waiting to be solved with the right tools. But Jupiter quietly reminds us of a deeper truth. Some limits are not technical, they are biological. Human beings evolved on Earth. Every system in our bodies reflects that origin. Our bones formed under a specific gravitational pull. Our cells function within narrow temperature ranges. Our chemistry depends on pressures and radiation levels that remain relatively stable. These conditions are not optional. They are the foundation of how we live. This means that when we imagine traveling to environments like Jupiter, we are not simply facing engineering challenges. We are confronting the boundaries of our own biology. Space rarely gives us simple answers. Technology can extend our reach, but it cannot rewrite the basic structure of a human body. A spacecraft can protect us for a time. It can insulate, shield, and regulate. But it does not change what we are. It only creates a temporary pocket where Earth-like conditions can be maintained. On Jupiter, the mismatch between human biology and the environment is not slight. It is fundamental. Gravity is stronger. Pressure increases continuously. Radiation levels are extreme. There is no stable surface. There is no atmosphere that can be breathed. These are not obstacles that can be removed. They are the nature of the planet itself. Even if technology could carry a person deep into Jupiter's atmosphere, adaptation would not follow. Human biology does not gradually adjust to extreme pressure or radiation. It fails. Cells are damaged. Systems break down. No amount of equipment can turn a human body into something suited for Jupiter. This distinction is important. Technology allows us to observe. Biology determines where we can exist. Robotic probes illustrate this clearly. Instruments can pass through Jupiter's upper layers and return data. They can endure conditions far beyond human tolerance, but even they have limits. Eventually, pressure and heat overwhelm their structures. The difference is not that machines succeed where humans fail. It is that machines are built to endure conditions, not to live within them. Numbers whisper more than they speak. The data we gather from Jupiter comes from brief encounters measured in hours or days. These moments are enough to teach us a great deal, but they also highlight how far we are from being able to remain there. Observation does not imply habitation. There is a quiet difference between knowing a place and being part of it. From a human perspective, this difference can feel disappointing. We are a species defined by exploration. We associate understanding with presence. To truly know something, we believe we must stand there, touch it, experience it directly. Jupiter challenges that belief. There are worlds where understanding does not come from arrival. It comes from distance, from careful measurement, from patient interpretation of signals carried across space. Silence is also a kind of data. The fact that humans cannot adapt to Jupiter does not diminish our knowledge of it. It refines it. It forces us to separate curiosity from conquest and understanding from occupation. Technology excels at extending our senses. Telescopes turn light into information. Instruments translate pressure, motion, and radiation into numbers. Spacecraft allow us to reach environments we could never enter ourselves. But none of this turns Jupiter into a place for human life. This is not a failure of imagination. It is a recognition of limits. Biological limits are not obstacles to overcome. They are boundaries that define who we are. Accepting them does not reduce our capacity for knowledge. It redirects it. When we accept that humans are not meant to be everywhere, our approach to exploration changes. We become more careful, more attentive. We listen more than we impose. Jupiter becomes a teacher rather than a destination. The difference between knowing and being there is subtle but profound. Knowing involves interpretation. It requires us to build models, test ideas, and revise them over time. Being there demands compatibility. It demands that the environment and the organism align. On Jupiter, that alignment will never exist for humans. The planet is not incomplete because of that. It simply exists on its own terms. This realization can feel humbling, but it is also clarifying. It reminds us that understanding does not require presence. It requires patience. Space rarely gives us simple answers. The more we learn about Jupiter, the more it becomes clear that our role is not to arrive, but to observe. To accept that some worlds will remain distant, not because we lack courage or creativity, but because the universe is broader than our biology. In this sense, acceptance is not retreat, it is progress. By recognizing the limits of adaptation, we gain a clearer picture of where technology is most powerful. It is powerful in observation, in measurement, and in interpretation. It is less powerful in transforming environments to suit us. Jupiter teaches us that exploration does not always mean presence. Sometimes it means restraint. Sometimes it means understanding that distance itself can be a form of respect. And perhaps that is the quiet lesson at the heart of this chapter. Growth in knowledge does not always come from going farther. Sometimes it comes from knowing where we do not belong and learning to understand those places without needing to be there at all. Jupiter was never meant to be a destination. It does not wait for arrival, and it does not invite us to stand upon it. The planet exists on its own terms, vast and self-contained, shaped by forces that do not pause for human presence. In this sense, Jupiter is not a goal to be reached, but a system to be understood. Distance, here, is not a failure. It is a form of clarity. The space between us and Jupiter allows us to observe without interference, to measure without disturbing, and to learn without imposing ourselves. What we gain from that distance is not less knowledge, but a different kind of understanding, one grounded in patience rather than proximity. Some worlds are not meant to be approached closely. They are not incomplete because of that. They simply operate under conditions that do not align with human biology or human needs. Jupiter is one of those worlds. It reminds us that presence is not a requirement for meaning. While we remain far away, Jupiter continues its quiet work. It turns steadily, maintaining its internal balance. Heat rises from within and escapes slowly into space. Winds flow in long, ordered paths. Gravity holds everything in relation, shaping motion without urgency. None of this depends on our arrival. For humans, there is a lesson in this steadiness. Understanding does not always come from moving closer. Sometimes it comes from learning to listen, to watch patterns unfold, to accept limits without frustration. Space rarely gives us simple answers. In choosing not to approach, we are not turning away from knowledge. We are refining how we seek it. By allowing some worlds to remain distant, we learn to respect the difference between curiosity and control. And perhaps that is where understanding truly deepens. Not in reaching every place, but in recognizing when distance itself is the most honest way to know.